Alright, here is the next lesson, equations as functions. In the last lesson, we talked about what a function is. Every input has to have its own output. You cannot have any x values repeating. So now we're going to move on to having equations as functions. So right here it says an x value is called the independent variable, meaning that because you pick it, x can be whatever you want it to be as long as it doesn't repeat itself, but x can be whatever you want it to be. And then the y value is called the dependent variable, okay? Meaning that whatever you plug into your function, then you'll... Alright, I wasn't just eating something, but anyway, equation is equal to x plus 4. This video is sponsored by these things right here, these cheese crackers. I'm not gonna eat the rest of it. They're good, but they're a bit too peanut buttery for me right now. Alright, you guys, I think I got myself together now, but so you have here an equation, y equals x plus 4. And we can create a table out of it by plugging in each value of x and then finding my output. Okay, so I'll do some by hand, but then we should really just put these in Desmos because Desmos does it so much faster. But anyway, -5 plus 4 is -1. That's my output right there. Y equals -4. All I'm doing is replacing the x value, so my equation is x plus 4, and I'm just replacing each of my y values, x values, okay? So 0, when x is equal to -2, I get +2, and then when x is equal to 0, I get +4. I'm going to do the next ones in Desmos, but that's what that is. And then we can take the equation, turn it into a table of values, and then we can graph those table of values right here. So -5, 1, 2, 3, 4, 5. Is that 4 or 5? -5, -1, -4, 0. 1, 2, 3. Oh, I did it wrong. So -5, -1. This point. Ignore that point. -4, 0. Erase that. That's right. I just made it not a function. I could take that off. This video is also sponsored by my whiteout. Okay. -2, 0. And then 0, -4, or +4. 1, 2, 3, 4. Okay, it really should have come out to be a line, so I did something wrong here. -2, 2 right here. Okay, there you go. I'm not going to start over this recording. You guys saw what I did. Anyway, that's what that is. So you have an equation, you have a table of values, and then you have a graph. And I can actually graph this because there's other x values. I can put all these other x values and still get a nice clean graph. Okay, let's do the next one in Desmos. Hey Desmos, here's this. I probably should just go home, you guys, right? Where are you? Okay, Desmos. So what I'm going to do is I'm going to go ahead and take my equation and just plug it in here. So y equals 3/4 x minus 2. And then this is how you can turn it into a table of values in Desmos. You're going to press this little button right here. And then there's your table of values. And then I'm going to go ahead and change my x values to what I have on my paper, which is -4, 0, 4, and 8. Take that one off. And then there's my output. So it looks like I have it at -5, -2, 1, and 4. And I mean, Desmos beautifully graphs the points for me as well. So let me just kind of, you can zoom in and out and then do that. But it's at -4 goes to -5, 5, 0 goes to -2, 4, 1, 2, 3, 4 goes to +1, and then 8 is off the graph, so I won't graph that one, but that's what that is. So we can connect the graph, and then we have it right there. And then I have here other two examples right here. Given each function and domain, so I have a function here, or an equation, and I have a domain, find the range. So basically what it's saying is I have my x values 4, 6, and 8, find the y values. So I can do that by hand, by just, plugging each x value here. So 4 minus 5 is -1, 6 minus 5 is +1, 8 minus 5 is +3. I just plugged in each of these values for x here. So x minus 5, so 4 minus 5, 6 minus 5, and 8 minus y, because my x keeps changing. And then so my range would end up being -1, 1, and 3. So I can do the same thing here in Desmos. And so all I'm going to do is take Desmos, and then I'm going to erase everything, plug in my equation. So y equals 3x plus 1. And then we're going to turn that into a table of values, change the table to -1, 0, 1, and 4. Take that off. And there's my range. So my range is starting from -2, 1, 4, and 13. And that's that. So here we go. I have showed you many ways to show relations, x and y relations, with a table, ordered pairs, mapping, graphs, and equations. For the table, you can find the domain right here listed out. You can find the range right here listed out. I really should have put those in order, but I did that completely wrong. Let me redo it. So the lowest number is -2, and then you have 0, and then you have 3. I'm not going to repeat the 3. And then you have the range where the lowest number is -4. Then you have 1, 2, and 6. Okay? And then is it a function? No, because my x value is so 3 is repeating, so it's not a function. We can also do we can also do ordered pairs right here. So the domain, it looks like it's at -1, 0, and 2. And then the y value here is at 2, 5, and 7. And is it a function? Yes, because the x values are not repeating. All right, mapping. The domain here is right here, -7, 0, and 3. And the range is at 1 and 2. And is it a function? Yes, because every output has a specific input. I mean, the other way around, every input has a specific output. Here with the graph, domain looks like it's from -1 to -1, 2, 3, 4 until +1. The range is from -2 until 1, 2, 3. And then it is not a function because it fails the vertical line test. You draw a vertical line, it has two outputs. And then you have an equation here. So for equations like this, I would go ahead and graph it in Desmos and check for it. So let me find Desmos. So you have y equals x squared this time, minus 1, and look at that. It looks like my domain is all real numbers. Okay. And then the range is y greater than or equal to, since it's going up. And on the y, the lowest number is at -1 right there. Okay. And it is a function. Yes, it is, because look, it has, you can do the vertical line test. You can draw a line, so like x equals, I don't know, I'll just put 1. And you can actually move this everywhere, and then it only has one y value. Okay? Alright, thanks guys. Thanks for watching.